If you have not already watched question 3, please start with that. This says give the theoretical Van Hoff factor I for the following soluble compounds. So first of all, it tells us they're soluble, so we don't need to worry about whether they dissolve or not. To find the Van Hoff factor, it's essentially how many species are in solution when this thing dissolves. So this is in the colligative properties section. So colligative properties means it's independent of the actual species and only dependent on the amount. So for example, things like osmotic pressure and freezing point depression and boiling point elevation are all going to be colligative properties. So a way to correct for the amount of species in solution is this Van Hoff factor term. So it essentially is a count of how many things you get in solution when you dissolve a certain thing. So if we were to dissolve NaNO3, it would break up into Na plus aqueous and NO3 minus aqueous. And I talk about that more in question 3. So here, I is equal to 2. Because if I dissolve one of these, I get 2 things in solution. For every mole of this, I get 2 moles of species in solution. So I is 2. Now, if I were to look at K2CO3, this is going to break up into 2K plus aqueous plus CO3 2 minus aqueous. So this one breaks up into 2K pluses and a CO3 2 minus. I is equal to 3 things. 1, 2, 3 things. Lithium hydroxide. Lithium hydroxide breaks into Li plus aqueous and OH minus aqueous. And these are the 3 examples from question 3. Here, I is equal to 2. Dissolve this, you get these 2 things. What about covalent compounds? Note that all of these contain a metal. This one does not. So what about covalent compounds? Well, this is just going to be C6H12O6 aqueous. It will dissolve, glucose dissolves in water, but it doesn't break up. So for this, for every one of these you do, you get one thing in solution. So here I is equal to 1. And then finally CaCl2. CaCl2 breaks into Ca2 plus because it's a 2A metal, plus 2 Cl minuses, 7A nonmetal, and you get 1, 2, 3 total things, so I is equal to 3. So you essentially need to know what the compound breaks up into when you dissolve it. If it's ionic, it will break up into its ions, as in these 4 examples. If it's covalent, I is equal to 1 because it does not break up.